Hello everyone and welcome to this Block 2 Week 5 homework review video. This is the mathematics video, and today we'll be going over the multiplication division questions, or the problem questions from pages 32 to 33 in the Minecraft book, and 40 to 41 in the Bond book. It's important to note today, guys, it's a bit of a review, so obviously some of the skills that we'll be going over you will have covered, but possibly we're looking at new questions in sort of different formats. And so if there are any things that you're not sure about, you may want to check back and look at some of the helpful review videos from weeks 1, 2 and 3, as those will include some of the hints as to how to complete these, but I will, wherever possible, try and cover everything. So in this book, we're starting with the Maths Minecraft book. Just worth noting that, of course, there was another English book and a separate English review video that we went through, where we went through the first part of the homework. So in addition to covering the book work, it's just worth reminding everyone, of course, that there is online homework, and today we're focusing on the number knowledge section, so just be aware that that's part of our homework. And again, with these questions, it's worth trying, please, 30 minutes per subject, or 3 attempts, whichever comes sooner. There's lots of sort of varied questions with it here, and it's well worth going through. We're learning about sort of things like prime numbers, factors, multiples, various rules in regards to divisibility rules and things. There's lots to go through here. So if you do find that there's things you're not sure of, things you need to look up or write down, please do take that time into account. So, if you do it once properly, you go through, you look up all the words you're not sure of, and that takes you 30 minutes, that's perfectly acceptable and well worth doing, because of course this is going to need lots of practice and there's plenty of things to cover. Right then, guys, so let's actually jump into the main body here. So we'll be starting with the Minecraft book, page 32 to 33, and the first page like this on 32. So, Rosa has heard of mysterious ships being moored off the islands of the End. She imagines there are 9 ships that each can carry 1,368 passengers. Each ship sails 19 times a year. What is the maximum number of passengers that can be carried in total in 1 year? So this is a whopping great question to start with. And so it's really important to give yourself plenty of room. One thing I would always say, and this is true of any questions, any of the books, the reasons we include the jotters, if you feel you need more working out space, more room, it's totally acceptable for you to use those jotter books to give yourself the space you need. So if there's not enough room, please guys, don't hesitate, do give yourself plenty of space. And actually on that note, I may just slightly move these up out of the way, just to give myself a bit more scribble room on the side. So there's a bit of a tactical choice here. We know we need to multiply everything, so that is the solution to this question. We're going to do 9 times 1,368 times 19, but in terms of preference, I might choose to save the smallest number till the end. I would rather do 2 medium-sized numbers and a big times a small than producing a large number and then timesing that by the next largest. Now, it's not really going to make any difference, but for me, that would be my preference. So I'm actually going to start by doing 1,368 multiplied by 19. And then I'm going to multiply that by each of the ships. So I'm going to work out how many one ship can do in the 19 times a year. That's what multiplying these will do. And then I'll work out what the 9 ships can do. It's going to give the same answer, but I think it'll just lead to slightly smaller results, which for me is slightly preferable. So the way this works, we have to do 9 multiplied by 8. Good trick for the 9 times table is to do the 10 times 8, which is 80, take away 1 lot of 8, which gives us 72. We've got to do 9 times 6, same thing, so that's 60, take away 6, which is 54, but I do have to add on my 7, which gets me then back up to 61. 9 times 3 is 27, plus the 6 is 33, and then 9 times 1 is 9, plus the 3 is 12. So that's my answer for the first row. I do this trick where I put the line then through the remainders, so I then don't get confused when I'm adding later. This is now quite friendly because it's 10 multiplied by 8 or 1 multiplied by 8, depending on whether you write the 0 first. So I'll put my 0 down now. I can just read it as 1 times 8 is 8, 1 times 6 is 6, 1 times 3 is 3, and 1 times 1 is 1. What I now should be able to do is add these together and get my answer. So that's 2, 9, 9, 5, and 2. And so 25,992 is the total number of ships, total number of passengers one ship can carry in a year. And so now I've got to multiply this number by 9. But it's not too bad because it's only a 1-digit multiplication. So let's write this out. So we've got 25,992 multiplied by 9. Lots of 9 times tables here today. I'm glad I got my backup trick. But the nice thing is, because I'm only multiplying by one number, I'm not going to have to do any adding, so this will be actually, even though it's a longer or a large number on top, relatively easy. So 9 times 2 is 18. Carry the 1. 9 times 9 is, well, 9 times 10 is 90, minus 9 is 81, so add the 1 on, brings us to 82. 9 times 9 again is going to be 81, but this time we've got to add on 8, giving us 88. Sorry, 89. And then we need to do 9 times 5, which is 45. But of course it's 45, plus the 8. Don't forget to add the remainders on. So 45 plus 8 is going to be 53. And then 9 times 2 is 18, plus the 5 is 23. So there's my final answer, which is 233,928. There we got there. Really good. So I hope that makes sense. Again, just a slight change in the order we did things in, but had you done 9 times 1,368 and then times 19, you'd have gotten the same answer. On then to number 2. Rosa is thinking about what she'll need to do to prepare for her journey to the end. She buys 35 stacks of carrot seeds, and each stack holds 64 seeds. God, that's a lot. She loses 800 and then loses another 800. Well, in my head I already know that's the same as losing 1,600, so I might just jot that down. How many does she have left? Okay, well the first step is to do 64 multiplied by 35. And again, whichever method you can use fastest is correct. I can use a column here, but you can use a lattice or a grid, but really what matters is speed. And for me, I do find this is the fastest of the methods. So 5 times 4 is 20. 5 times 6 is 30, plus 2 is 32. Because it's a 30, we add the 0. So now we can say 3 times 4, which is 12. 3 times 6 is 18, plus 1 is 19. Add them together. And we end up having 22, plus the 1, plus 2 is 3. Oh, no, it's not right. It's, be very careful, that should be a remainder 1, and that should be a remainder 2. 2,224. But of course we are then losing 1,600. So you might be able to do that in your head, because it's just 22 minus 16, but if not, listing it out, making sure it's nicely lined up as a subtraction will work as well. And you can see here we're going to end up doing 0, 4, borrow the 1, 6, and the answer is 640. So there are 640 carrot seeds remaining. Hopefully that's clear. I am going to rub this out as I'm working out just so I can make space for doing these next ones. But hopefully that's nice and clear. And again, if you can do things in your head for like the second section, absolutely feel free. I would probably do this multiplication written method just to make sure. But I think that's very useful. Right, number 3, complete the following calculations. Something divided by 28 is 98. Well, if that's true, whatever this something is, it will be the same as 98 times by 28. So with these questions, if you're ever unsure and you need to prove to yourself how it works or why it works, you could set yourself up with a similar question. So something divided by 2 equals 10. This is a good example for working out because they're quite easy numbers. And I've intentionally picked 10 that can both be both doubled and halved. And now if I think about what's going on, well, the number that can be divided by 2 and equal 10 is 20. But I can now use this easy example to just remind myself of the method, and that if I wanted to get that 20, I would do 2 times 10. And I'm now applying that same logic to the much more complicated numbers here. So this is a lovely skill to be able to have either by writing it out or just by thinking in your head. How would I do it if it was easy numbers? And bingo, now I've got the method, I can apply it to these much harder numbers. And we are going to times these two together, and this is the reason why. So again, I wouldn't necessarily write this one down, but just being able to come up with an easy example where you know what's going on can sometimes remind you what to do on those much harder ones. Okay, let's have a look. So 8 times 8 is 64. 8 times 9 is 72, but plus the 6 is 78. Then we've got to do 20 times 8, so let's add the 0. Now it's like 2 times 8, which is 16. 2 times 9, which is 18, plus 1, which is 19. So now we can add these two together, so we've got 4, 14, we've got 16 plus 1 is 17, plus 2. So I think the answer is 2,744, which it is. Very good. Right, the next one. This is going to work in a very similar way. I'll just see if I can put this off to the side where we can sort of keep it but not in the way. Something times who knows what equals 472. So if I was to do 472 divided by 32, I should get back to my answer. Now, again, this looks like a scary bus stop, but I sort of have faith that the numbers are not going to be so impossible, and so if I follow the process, it should all work out. Let's see what happens. So obviously 32 does not go into 44, so we carry the 4. Now it does go into 47, it goes in one time. If I can't do it in my head, I'll just do the subtraction to work out the difference, because that difference will be the remainder. So that's going to be a 5 and a 1, and then we've got 152. And now I'm going to assume that 152 does go in relatively nicely, but let's see, and if not, we have a decimal, we can always keep going. Let's do my 32 times table down the side, so 32, 64, 96, a bit harder, but what I'm doing is I'm using this to help me, so 2 plus 6 is 8, 3 plus 9 is 12, so 128. Add these two together, so again, we've got 2 plus 8 would be 10 carried. That adds up to 5 plus 1 is 60. And 1, so that's going to be 160. And oh, so it doesn't actually quite go in, so it's going to be 1, 2, 3, 4 times. And again, if I need to, I can do the difference between 152 and 128. I can subtract them. So that's going to be a 4 and a 12. So 12 take away 8 is going to be 4. 4 take away 2 is 2, and so there's 24 left over. And at this point I'm left with a choice, because obviously this remainder 24 is not the kind of answer I'm going to want to leave for this particular question. So I can either keep going with the bus stop method, and that would work, or we can utilise our understanding of the remainder to leave it as a fraction. So this would be 14, and that 24 remains to be divided by 32. And one thing I have noticed is that if I was to write it like this, it's actually quite a nice fraction to simplify, and that's because I can see they're both clearly divisible by 2, as well as being actually divisible by 4. So if I was to divide both of these by 4, actually also as well as being divisible by 8, and you can see there's some quite large numbers to be able to divide by. Let's say I go with the first one I spotted, which is to divide by 4. I know that this goes in 6 times. I know this goes in 8 times. And that's a fraction is 3/4. So I know the answer is 14 3/4, or 14.75. And that's the power of what we did on that last division lesson, where just understanding what the remainders means you can actually simplify quite quickly. If you didn't like that, you didn't want to go through, the other way of course would be to extend your bus stop, give yourself a 0 with plenty of space, and then you can write down the remainder 24 here. I can already say up with confidence that 32 is going to go in 7 times, so we have to just work out what 7 times 32 is, and again you could do this by calculating, by adding up each time, or by working out, so I think that's going to be, just from quick math, is going to be 224, which is 7 times, and then the difference between 240 and 224 is 16, and from my notes earlier we can see that goes in 1, 2, 3, 4, 5 times, so you do get the same answer. So that was 2 ways to get your decimal answer there, but again that is a challenging question, so well done if you're completing these. These are sort of the high-end, high-level skills, and they really show you've absolutely got this mastered and nailed, which is fantastic. Even if you just got to 14 remainder 24, well done, that's really good progress. Right, so I'm definitely have to clear that up because that's far too much jottings and notes, but I suppose I might better keep this one off on the corner, so let's just take that now. put that off to the side. So we've got to do a large division. So 4770 divided by something equals this. But if I divide it by the 265, I'll end up with our other answer, other number. So 4,770 divided by 265. Oh, I'm doing about to do subtraction, sorry. Divided by 265, let's write that properly. It must be an autopilot. Divided by 265. Let's do that like a bus stop. It's going to be a very big numbers, but let's see how it goes. So, we obviously know it doesn't go into the first one. We obviously know it doesn't go into the second one. That wraps up the 47, and then we've got the 477. So now we need to do our 265 times tables. I'm not expecting anyone to know these times tables, so we're definitely going to have to write these ones down. And I would say this is certainly pushing the higher end of the kind of thing we might be expected to do, especially if they go on for too long. But I will show you there are some tricks that we can do if we think they do go high. But luckily for this first one, actually I can see already that if I double this, it's not too bad, because I can do double 65, which is 130, double 200, which is 400. That's going to be 530. That means I can see that it only goes in one time. And the remainder is going to be the difference between 470 subtract by 477, excuse me, let's write that down properly. 477 subtract 265, which is going to be 2, 1 and 2, so 212. So this is now leaving us with a very large number, and again, I don't necessarily want people now having to add their 265 times table multiple times. It looks though to get up to the 2000s, it's going to have to be quite a lot. So my sneaky trick is that I'm actually going to start off at 10 lots of 265, which is 2,650, and work backwards. I'm going to do that obviously by subtracting. So 2,650 subtract 265. Again, if you can do it in your head, great. If not, it's only going to be 2 subtractions to get down to where we need to be, roughly, to get within that 2,000 range. So if I subtract 265, that's going to give us the 4 and our 10. So there's our 5. We have to borrow again, giving us the 5 and 1. So we've now got 14 subtract 6, which is going to be 8. 5 subtract 2, which is 3. So that means that we know that 9 lots are 2,385. If I do one more subtraction, I'll just do in the space here. We've got 22,085. Actually, 2,385. Subtract 265. 5 take away 5 is 0. 8 take away 6 is 2. 1 and 2. And here is our number. 2,120. And hopefully you can see how it was much faster to go back from 10 than it was to go all the way up from 2 to 8. That means there was the difference between 2 sums versus 6 additional sums. Now, this is quite a challenging question, guys. It's not an easy one to get the answer of 18 there, but it's one that's, if you can master it and you can be confident with how to manipulate, you're going to be absolutely set for anything they can throw at you. Normally, whenever we're doing larger division like this, where you've got 2 or 3 digit multiplication, I would never really expect there to be a remainder. So actually I think B is a bit of an exception, that had a decimal. I would expect it to either have decimal answers for 2-digit division, or if you are doing double-digit division or triple-digit division, they should be relatively nice, easy numbers that do go in. So as long as you sort of trust the process, you will end up with an answer that does work out in the end. So there's our answer, 18. Right, let's then put these off to the side. Again, I'll leave the division on the right-hand side here, so we've got something to refer back to in case you need it. But that was a challenging one. Obviously, in fact, I have to say B and C both seem like quite hard. Something on the higher, very much on the higher end of difficulty. Right, last one. I like this one already because it involves a remainder, so it makes us really test and understand what's going on. So something divided by 37 equals 86, and there's a remainder of 23. So to do this in reverse, I need to do 86 multiplied by 37, And then whatever my answer is, we'll have a remainder of 23 left on, so I'm going to work out the answer, and at the end I'm going to add 23 to find my starting number. This is the journey I'm about to go on. So 7 multiplied by 6. If you're not sure about your 7 and 6 times tables, I know this is the one that often catches people out. If you do, for example, 5 times 7, which is 35, add another 7 on, which gets you to 42, you have your answer. That's quite a nice way of working it out. Again, similar with 7 multiplied by 8. If you know, for example, your 8 times 8 and subtract down, that can work. Or also just learning, this is one of the sort of harder ones because it's kind of equally between the 5 and the 10, which are one of the easy ones you can add up from. But equally, you could do 5 lots of 8, which is 40, and then add 2 more 8s on, which is 56. That's a good way of doing it. But either way, 8 times 7 is 56, and then 56 plus the 4 gets you to 60. So 602 goes on top for my first row. Then I've got to do 3 times 6, but it's a 30, so we add the 0 in. Now I can say 3 times 6, which is 18. 3 multiplied by 8 is 24, plus the 1 is 25. So then we've got to add them all together. So that's going to be 2, 8, 11, and 3. So 3,182. But remember, that's what the number would be if there wasn't this remaining 23 left over. So we need to add the 23 on. So, and this we could do in our head, or we could do a bus stop. I think I'm going to try and do it in my head. So that's going to be 2 plus 3 is 5. 8 plus 2 is 10, so 0, carry the 1. That's going to be plus the 1 there, so it's 2 and 3. So I think my answer is 3,205, which it is. I have to say, of the two, I think A and D, of the 4, the 2 I think are more likely A and D, where the solution involves this 2-digit multiplication. But I say, if you've managed to do B and C, really well done, because those are proper challenge questions, and to be fair, they are the final problem questions at the very end, to show you sort of mastered all these skills. On now to question 4, and so the answer here should be hidden away. Let's quickly do that now. So we will go through them and reveal them at the appropriate time. So, number A. What is the total cost of 37 oak trees and 15 acacia trees? So 37 oak trees is going to be 37 times £4.50. So we need to have a method for dealing with decimals. And to it, we're going to add 15 acacia trees, which is going to be £3.50 multiplied by 15. Now I'm actually going to split this up into 2 different ways, because I know in the past I have talked about sort of the 2 methods of multiplication. The column is probably the best method for just simple numbers, but I do have an alternate method that I like to use when dealing with decimals, and it's the lattice method. So I'm going to do the lattice method for the first one, and then I'll show you how, if you don't like the lattice method, you can still use normal column multiplication for the second one. So the way the lattice method works is you create a grid equal to the number of letters. So I've got 4.5 multiplied by 37. So you can see each number gets its own box. I then divide each box from corner to corner, making sure to extend a little bit out the bottom left hand side, because that's where my answers will go. We then cross multiply to fill out the boxes, so 5 times 3 is 15, 5 times 7 is 35, 4 times 3 is 12, and 4 times 7 is 28. We now add along the diagonal, so this one adds up to give me 5. Here I've got 8 plus 5 is 13, plus 3 is 16, so carry the 1, write the 6. And then we've got 5 plus 1 is 6 again, and then just a 1. So my answer involves the digits 1, 6, 6, 5, but I've got to take into account the decimals, and the way the method works is you want to try and link the decimals up. Now, the decimal for 37 would actually come after the 7. So when I then meet these 2 decimals and work out what diagonal they match along, is this one here. And so that's where the decimal belongs. So now to return this answer, it would be 166.50. Now remember, that's not the final answer, that is just the cost of the oak trees. I still need to work out the cost of the acacia trees, but that's still that first one done and dusted, which is good. So you could, if you like the lattice method, you can see how that works. It's a really good one. Ooh. I will leave it on the screen because that's just a really good one to have sort of in your in your tool belt for ways of dealing with these questions. Let's just swap these over. I'll leave that up there and you'll have a look at it, and you could try this one using that method if you want to, the 3.5 times 15. The other way of doing this is to basically pretend the 3.5 is a 35, do the column multiplication as normal, and then revert the change. So in this case, in order for us to pretend 3.5 is 35, we have to, in our brain, remember, we've basically times it by 10 to get it to be 35. So then whatever our answer is at the end, we're going to have to undo that change by dividing by 10 to get it back to our answer. That's going to be our method. Let me show you what it looks like. So 5 times 5 is 25. 5 times 3 is 15, plus the 2 is 17. Then we've got 1 times 5, so let's add that in so we can make it a 10 times 5. Now 1 times 5 is 5. 1 times 3 is 3. Add these together, and we've got 5, we've got 12, and we've got 5. So my answer is 525, but I've got to remember that is what the answer would be if it was a 35, which is 10 times bigger. It's not going to be that, so our answer is actually going to be 10 times smaller. So once I divide it by 10, I actually move the decimal one place back, and that gives me 52.50. Remember, I'm adding in the 0.50 because it's actually a money. And let me just add the decimal in nice and clearly so you can see, so 52.50. So now what I've got to do is I've got to add these two things together. So let's find myself some space. So we've got 166.50 because it's money, plus 52.50. When I add these together, I get 0, 0 carry 1, 6, 7, 8, 9, 11, and 2. So my final answer is £219, which is the correct answer there. So I hope, guys, that's useful, makes sense. It's a big question there, lots of steps. So if you're managing able to do these and follow along, really, really impressed, really, really pleased. Now, of the two, for decimals, I actually must say I prefer the lattice method. Although, as you've seen, I do tend to like the column method for anything that doesn't involve decimals. And the reason I don't like it when it involves decimal numbers is people often forget that last step of dividing by 10. So they work out 35 times 15, and they just leave it as the 525, which is obviously 10 times too big. And so to avoid that little mistake, that's often why I'll make that one change. So for B, I just need to make myself a bit of space. I'll leave the top one because it's just the most different, but I'll use the space underneath here now. So we've got a forester has £357 to spend on birch and acacia trees. He wants to buy 23 birch trees. Well, I'm going to work that out to start with because that is 23 times 7. This one might be something we can do in our heads. We can do 20 times 7 and 3 times 7. Or, again, you can use a column multiplication. It's much the same. So 7 times 3 is 21. And 7 times 20 is 140. So we add that on, we get 161. So he's going to spend £161 on birch trees. Now that means we can subtract them from each other. We can do 357 multiplied, or subtract what we spend on the birch trees, which is 161, and that will give us our amount of money that we've got left over to spend on acacia trees. So we need to then do that's 6. Borrow from that, making a 2 and a 15, meaning it's a 9. So we have £196 to spend on acacia trees, which means we've got to do a division. Now, this is one where there's a good trick for this, because I really don't want to divide by a decimal. So the trick I'm going to do is I'm going to say to myself 196 divided by £3.50 is equivalent to, sorry, let's make that look like a £3.50. Let's rub that bit of the 5 out there. Or 3.5 is equivalent to the same as 1,960 divided by 35. And because these are equivalent fractions, I've done the same to both the top and the bottom. Whatever the answer to the one on the right is will be the same as the answer to the question on the left. And so that's how we're going to work this out. So we're going to do 1960 divided by 35. My words are failing me today, but we'll muddle on through. So let's write it out. So 1960 divided by 35. And the answer to these questions will be the same. So whatever I work this out to be, that actually is going to be my answer, which is good. So we have to do 35 into 1 doesn't go. 35 into 19 doesn't go. 35 into 196. Now that is going to go. And it's our job to work out how many times. So I need a space to put it. I'm going to use, well, I might have to finally clear this one out just so I've got some room to jot down my times tables. So we've got 35 doubled is 70. I can spot that I need a bit more. So what I might do actually is a bit of a trick. I might double it again to 140. So I now know that's 1 time, 2 times. This is actually then 4 lots of 35. I can add it on again and give myself 175. That's 5 times. I think that's probably my answer. Let's just check by going up to 6. So if I were to add on 30, that would make it 205, so it's 210. So yeah, look, I've shot past. So I know my answer is going to be, it goes in 5 times. The difference between 196 and 175, I can work out now. That's going to be 1 and 2, so 21. So we've got 210. And looky here, I'd already worked it out. 210 goes in 6 times. So that means I've got exactly enough to buy 56 acacia trees. And that is the answer. There's no putting things back or working things out. I think here, look, I had 196 ready to go. So that's how much we had to spend on it. So that is my answer. And again, just to be clear, I'm not then dividing that by anything because these are equivalent fractions. Equivalent means equals. So the answer to this is equal to the answer to this. So I hope that makes sense. Good little method for that one. Right, let's clear these out so I've got room for number C. For number C, we've got new trees delivered in lorry loads of 900. How many lorry loads are needed to deliver 9,600? Oh, well, there's a really good trick for this one that's going to make this a lot easier. Also sort of using our understanding of fractions. So I need to do 9,600 divided by 400. Well, I can actually simplify this by dividing the top and bottom by 10, which means this is actually equivalent to 96 divided by 4. And a good trick for dividing by 4, again, bus stop would absolutely work for this one, but if you do 96 halved, which is 48, and then 48 halved, which is 24, that is the answer. And so to times by 4 or divide by 4, you can double or half. And in this case, 96 halved and halved again, so it gives us our answer of 24. And so it's going to be 24 lorry loads that we need. So that's a really nice trick for actually doing this last question mentally. And if we can do these questions mentally, it's obviously lovely to be able to do them. Also nice to be able to have a fallback. So remember, if you needed to, you'd do 96 divided by 4 in a bus stop, and that would also give you the answer. Right, final question now. We've got to do question 5. So there are 12 areas of birch trees. There are 50 birch trees in each area. So it's going to be 12 times 50. 28 birch trees are cut down each week for 2 weeks. Then 29 birch trees are cut down each week for 6 weeks. How many trees are left? I'm sorry guys, again I should have covered the answer before we go through it, but let's actually talk about the maths involved here. So there's quite a lot going on. So first off, we need to work out how many trees to start with. So I think that's going to be 50 multiplied by 12 is our starting amount of areas of trees and trees in each area. So that's going to be our starting number. So that's going to be 0. That's going to be 100. Then we've got, add the 0, we've got 0 and 5. So I think we start with 600 trees. And then we're going to start with 600, but we're going to subtract. Let's actually work out. We're going to subtract 28 times 2, which I think we could probably do in a head. That's going to be 56. And then 29 times 6. Maybe that one I would do a multiplication for, because that's how many we're going to be lost over the next 6 weeks. So 6 times 9, we've talked about this. You can do 60, take away 6, which is 54. It's a nice way of doing 9 times tables. 6 times 2 is 12, plus 5 is 174. So we have to do 600 minus 56 minus 74. You could do it in 2 steps, or you could combine this by adding 56 and 174 together. And that's quite nice for this particular number because you've got the 6 and the 4 that go quite nicely. So it's going to be the same as 600 subtract 230. And 600 subtract 230. Again, you could possibly do that in your head. It's 370. But if not, you could always send it out with a column subtraction. But I think the real secret of this one was just being a bit organised, keeping track of everything, so I can see my starting number I worked out up here, then I worked out what I was subtracting from the 2 weeks, then what I was subtracting from the 6 weeks, and then I worked out the total. So a few ways to get that last one. So number 5, I quite like that one. Right guys, give yourself a score. You can fill in your emeralds. Again, don't be concerned if you didn't get all of this right the first time. If you had to watch the video, that's exactly what these are here for. Some of these are bigger and larger numbers. I certainly think number 1 was a nice multi-step question, which was good. I think number 2 had plenty going on. That's got some quite good maths involved. I think these ones here, these are perhaps the hardest, A, B, C. I think of the two that I'd be least concerned about is if B and C we found those challenging. Those are a bit off the end of the difficulty spectrum, I think, slightly. However, A and D were certainly very valuable. And then these last ones here with the money, again, challenging perhaps with the decimals, but hopefully you've learnt some new tricks, and we are going to be revisiting these fraction skills in later blocks as well, so this is not the only time we'll be doing these, so please don't worry. This final question, this was a very good question. Certainly this is the kind of thing where I think they can expect you to handle a few things going on at once. None of the individual parts were too difficult, but what made this one hard was just keeping track of all your numbers and working out what's going on. So we're now going to move on to the How Am I Doing section of the Bond book, and so for this it's obviously a bit of a revision of all the different topic areas, so we'll dart around, and if there's anything you're unsure of, it's worth revisiting or perhaps highlighting with your tutor, because sort of each question jumps onto new and different topics. So for A, the temperature is -8, how much must it rise to get to 6? So the way I want to visualise this is to get from -8 to 0 is going to be a change of 8, and to get from 0 to 6 is going to be a change of 6. So the total change is 8 plus 6, which is 14. Same idea. I want to go from 11 to 0. I know that's a change of 11. And then from 0 to -3 is a change of 3. So in total it has to drop by 11, then 3. So that's another total of 14. So we've actually had 2 14s there. And for number C, it starts at -14. It has to get to 0. And that takes 14 steps to do that. And then from 0 it gets to +14. And that's another 14 steps. So in total we've made a difference of 28 jumps, 28 steps. Calculate the answers. So for these I've mentioned for decimals I do like the lattice method. So I'm going to quickly create myself a little lattice. 6.7 multiplied by 8. Now I just fill the lattice in. So 7 times 8 is 56. Again, if we don't like 6 times 8, we could do 5 times 8 is 4. Well, 5 times 8 is 40, so 6 times 8 is 48. Nice little way of doing it. We add up down our diagonal columns, so in this one there's just a 6. Here we've got the 8 and the 5, so 8 plus 5 is 13, so carry the 1, write the 3. And we've got 4 plus the one we carried, to give us a total of 5. But our answer is not 536, because we need to work out where the decimals are. The decimals are here and here. So the diagonal line that they meet on is this diagonal here. So the answer is 53.6. So that's one way of doing this. The other way, of course, is to pretend like it's not a decimal. So you'd do 342 multiplied by 5. But you then need to be able to revert it back at the end. So this number here has been times by 100. And so to put it back at the end, we're going to have to divide our answer by 100. Once we work out what the answer is. So 5 times 2 is 10, 5 times 4 is 20, plus the 1 is 21, 5 times 3 is 15, plus the 2 is 17. So 1,710 would be the answer if that was the hundreds, but we know our answer is 100 times too large, so when we divide by 100, we end up moving the decimal back 2 spaces, so it's going to be 17.1 or 17.10, both would be acceptable, and so that's going to be our answer, and there it is, look. On to number 3, calculate the following divisions. So this one's just a simple bus stop, I'm certain. So 2, 4, 8. 6 into 2 goes 0 times. 6 into 24 goes 4 times. 6 into 8 goes... Now, I don't know if it wants it as a remainder here, so it goes in 1 time remainder 2. So this, for completeness, just think about the 3 ways we could leave our answer. So it could be 41 remainder 2. It could be 41 and 2 over 6, which is equivalent to 41 and a third. Or we could use the decimal method where we sort of just keep things going, and so I'll move this sort of slightly down out of the way just so it's not got the FOIL workings in the way. So we know the remainder is 2, so we could create a space for us to put it. The remainder goes here on this 0. And now 6 into 20, that is going to go in 3 times remainder 2. I detect here a recurring decimal, and that 333 is going to go on forever, which is why it's a third. So we'll have to see what they left the answer as. Well, that's just correct. 43.3 recurring is allowed. Now, since it didn't say, my preference, especially with a recurring decimal, would maybe be this one here, because it seems like the easiest, 41 and a third, or 41 remainder 2. But just be aware, guys, you've got to keep an eye out for clues in the question. In the actual 11 plus, it'll often be multiple choice, so you need to just pick the multiple choice answer that best matches. But it's important, I think, that you've got the ability to use each of the 3 methods or each of the 3 representations. So we've got here then 312 divided by 13, so let's just write it out. Actually, that's not a very good bus stop. I should move that down slightly because otherwise I'm not going to have room to leave my remainders. It's very important, guys, when you're doing this, give yourself lots of headroom at the top of your bus stop so you can write your remainders in. So 13 will not go into 3. 13 will go into 31. I'm just going to jot it out. So 13, 26. So I know it goes in 2 times. The difference is 5. If I keep going, that's going to be 39. 39 plus 13 is going to be, I think I've got it. 50, I was going to say 52, and I've put the 5 in the wrong place. 52. Which means it goes in very nicely 4 times. So the answer is 24. And that was nice on number B. No nasty decimals to deal with. Will the answers be odd or even? So the nice thing about this is we don't actually have to work out the answer. Just by considering 2 odd numbers will always make an even number. And so even is the answer. Here we've got 2 even numbers. 2 even numbers will also make an even answer. Here we've got an even and an odd. An even and odd will always make an odd answer. And there it is, look, there's an odd answer. And finally, we've got an odd and an odd, and that will always make even. So as I've written down the actual numbers here, but in terms of what you need to write down, I think it was odd or even. Obviously, I've just written the numbers in so we can check and sort of prove it to ourselves. But as a rule, if they're the same, so odd or even, if they're the same, it will end up being an even number. And if they're a mix, a combination of either 1 odd and 1 even, or 1 even and 1 odd, then end up being an odd number. And that's worth noting. The other trick that you could also do is if you just add up the last 2 digits, that will decide. So adding up 6 and 2 gives you 8, adding up 7 and 1 gives you 8, adding 7 and 9 gives you 16, which of course ends in a 6, and then adding 4 and 3 gives you a 7. So that's the other way of doing it that's also relatively easy. Right, on then to page 41, there's a bit of percentages here. Again, some of these simpler ones you'd be expected to know. So half is 50%, that is one we would just expect you to learn. 0.1 is the same as 10%, I think you'd expect to learn that one. And that 1 is 100%. The reason is, remember, percentage means divided by 100, so obviously 100 divided by 100 gets you back to 1. And so actually for all of these, if you wrote 10 over 100 and 50 over 100, the fraction or decimal you'd end up back at is these first ones. That's the reason why. This one you might be expected to work out. So again, just realizing, what does 23 over 100 mean? It means 23 divided by 100. They're the same question. So if I move the decimal back 2 spaces, I'm going to get 0.23, and that is the answer. So I wouldn't necessarily expect you to write that out, but understanding how it works is really important. 0.7, so what would give you 0.7? Well, 70 divided by 100 would equal 0.7, and therefore 70%. So you can sort of work your way through that logic there. And again, 1 divided by 5, we can make that equivalent to 2 over 10, and we can make that equivalent to 20 over 100. And again, we always for percentages want to be back to over 100 because that is what percentage means. And so as soon as I see this, 20 over 100, I know that the answer is 20%. And that's the way of doing it. Round these numbers to 2 decimal places. Well, 2 decimal places, remember, means we count from the decimal. So it means this is a number that we're rounding. So it's going to be 567.98. And the reason it's 98 is the 1 will not round the 8 up. Again, still to 2 decimal places, that's now the 8 that may or may not be changing, and it will this time round up because the 7 decides that the 8 rounds up, so 0.79. So again, here's our decimal place. This one here is the 3 that will decide if it rounds up or not. So that's going to be 4.3, and it won't round up, so it stays the same as 4.33. Again, here's a number that might change, here's a number that will decide it. So that's going to be 67.68. This time it did round up because the 6 rounded the 7 up. So again, here's a number that may change, here's a number that may decide it. So that's going to be 33.93, because the 9 does round the 2 up to become a 3. And last but not least, here's the number that may change, here's the number that will decide it. So we've got 1.97. There's my answers for that list. Hopefully that makes sense. Right, on to the last little bit now. So we've got number 7. Join the dots to indicate which unit of measure. So these are really good. These questions do come up, and it's just worth sort of having a rough idea of what these things mean. So I think certainly the height of a tree would be measured in meters. That one jumps out to me. The contents of a mug, well, that's going to be volume. So I think we're going to want to measure that in some kind of litres, and millilitres makes sense to me. Now, we've got 2 measurements left, centimetres and grams. Well, one of those is for weight and one of those is for distance. So I think it's going to have to be the weight of peas is in grams and the width of a calculator is in centimetres. So that makes sense to me, hopefully to you too. Give yourself a score at 27 and make sure to record it at the front, because that is the end of the homework. Really well done, guys. I know that was quite a lot, but hopefully some of those made sense and hopefully the videos were useful. Keep working on these over the course. Don't be afraid, of course, as well. With the online, you can always go back through and revisit all the separate sections, and this is something I would be incorporating now into my revision over the course of the year. You can always pop back and try and improve any areas, bring any percentages up higher and higher, and certainly on this side of Christmas we'd expect you to sort of select from both the 9 to 10 and the 10 to 11 question, so you can sort of home in exactly on the difficulty and the practice that you need. Thanks for your time, everyone. See you again next week. Bye-bye for now.